Okay, Bismillahirrahmanirrahim. Today we continue for the counting. For the counting, basically this one is topic 12. Topic 12, counting. Okay, for counting, basically in the counting theory, we have several topic to cover. First one is the sum rule and the product. Secondly is the product rule. Thirdly is the permutation, and lastly is the combination lah. Okay, for the combination, the order is not important, and then for the permutation, the order is very important lah. Okay, for the permutation is the arrangement of some element in which order matters lah. In other words, permutation is ordered combination of element lah. Okay, it is a subset of combination lah. Okay, later we see the example lah. Okay, then a basic counting principle for the counting problem are the following kind. How many different add later password are there? How many possible ways that there are to pick 11 soccer players? Okay, we are defining the domain out of 20 players. Okay, most of the time, uh, this one is composing the probabilities of discrete event. Okay, and then lastly, what is the probability of winning the lottery? It is 50-50%. Okay, first one is sum rule that I explained before is the sequence of tasks. For example, we have this one sum rule. We have T1, T2, okay, dot until Tm. It can be done in ways. Ways 1, ways 2, comma, ways 3 until ways m respectively. In the condition is no task can be performed simultaneously. This one must be in a parallel. If we consider two tasks A and B, which are disjoint, example A, okay, we have A, okay, this disjoint by B is equivalent to null element. Then mathematically we can see that A union B is equal to element A plus element B lah. Okay, so far do you have any question? Okay ke? Later we see this one in details lah. Boleh ke? Okay. And then for the product rules, for the product rules, it is if a sequence of tasks T1, T2 until Tm can be done in ways 1 also same, ways 2, okay, until ways m. Ways respectively, and every task arrive after the occurrence of the previous task. This one is come after this one. Okay, T2 come after T1 and T3 come after, okay, after T2 lah. Okay, then there are W1, we can multiply by W2 dot until Wm lah, ways to perform the task lah. Mathematically, if the task B arrive after task A, then we can say A multiplied by B is equal to element A multiplied by element B. Okay. And then number 3, we have permutation, which order is important, and then we have a combination. Okay, we have a permutation and combination. Okay, combination is selection of some given element which order is does not matter lah. The number of all combination is n things and taking the r element lah. Okay, this one is for this one exclamation mark is factorial factorial sign. Okay, later we see this one. Okay, basic counting principle. This one, I repeat again. If the task can be done in one ways, then second task and two ways. And if these two tasks cannot be done at the same time, okay, as simultaneously, then n1 plus n2 ways to do either task lah. For example, if the department will award a free computer to either a computer science student or a computer science professor, and then the question is how many different choices are there? If there are 530 students and 15 from 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 the faculty are the professors. Okay, so the sum of 530 plus by 15 545 choices. Okay, and then for the generalized sum rule, okay, no of these two tasks can be done at the same time. This one I've explained. This one is not simultaneously. Okay, and then there are n1 plus n2 plus n until nm ways to do one of these tasks. Okay, okay, and then this one is the product rule. Okay, okay, is the successive task. If n1 ways to do the first task and n2 ways to do the second task after the first task. This one I explained. We have T1, we have T2. T1 is T2 is done after T1, and then T3 is done after T2. Okay, boleh ke? Haris boleh, Haris? Okay, if you have a procedure consisting of the sequential tasks, this one must be sequential because we have T1, T2, T3 done after T2 done after T1 and then T3 done after T2 lah. Okay. Okay, and then for example, here how many different license plates are there that contain exactly three English letters lah. Okay, from here we can see three combination. Okay, three English letter. Basically, for the alphabet, we can have from A to Z is 26. So from the three English letter, we have a three. So 26 multiplied by 26 multiplied by 26, we have 7,000 combination, possible combination, 576. Okay. Okay, there are 26 possibility to pick the first letter, then 26 possibility for the second one, and 26 letter for the last one. Okay, and then for the sum rule, this one I explained. We have any element from one of these element is we have union. Union. Okay. Okay, union. If we consider two tasks A and B which are disjoint, and then mathematically we can have A union B is equal to A plus B lah. Okay. Okay, this one is the broken down into two successive tasks lah. This one I have explained T1. Okay. T2. T2 is done after T1 lah, successive lah. Okay. And then permutation and combination. Again, for the permutation, Okay, permutation again is the arrangement of some element which order is matters. Is in other words, a permutation is an ordered combination of the element. Okay, and then for the combination is a selection of some given element which order is does not matter lah. Is doesn't matter lah. The number of all combination of things are given in the formula lah. Okay, for example here, how many different set of three people can we pick from a group of six? Okay, we have group A, group B, group C, group D, group E, and group F. And then each of this, okay, we have six people. Okay, so if we go by the uh, okay permutation combination. Okay, this one is C, C3, C6. Okay, okay, we have C and R is equivalent to N R and minus R factorial. Okay, this one is the formula. This is not the correct result. For example, if the picking person is C, then first person A and then person E leads to the same group of first picking E, then C, then A. However, these cases are counted separately in the above equation. Okay, and then permutation and combination. Combination is defined by C, represented by C, and permutation is represented by P. And then for above example, above question, order is important, order is not important for the combination. Okay, how many different set of two people can we pick from the group of three is N. And R is the okay, R is the element. R is the element. Okay, for example here, how many? Okay, we have element, and then N is a distinct option. Distinct option. Here is three. R is 2. Okay, so we can have 3 here. Okay, for example, we have A, we can have from group A, from group C is equivalent to C and A. Because its order is not important, this one is combination problem. Okay, so N factorial is equivalent to N uh, multiplied by N minus 1, multiplied by N minus 2, and so on. So 3 factorial is equivalent to 3 multiplied by 2 multiplied by 1. Okay, this one 3 factorial. Okay, or you can use the formula. N is the distinct option. Okay, 3 lah. N and R is the element. Okay, for this one, so how can we compute this problem? To find out about this, we need to look at permutation. A permutation is a set of distinct objects and ordered arrangement of the object. Remember, permutation is the arrangement. Arrangement is very important. So, an ordered arrangement of R element of set is called R permutation. If you look this one for the R permutation, okay, R is the element because if associated with the set, we call it as the R. R is for the element. Okay, R is for the element. So if you take a look for the set, set 1, 2, 3, arrangement is 3, 1, 2, permutation of S. The arrangement 3, 2 is a 2 permutation of S. So the number of R permutation is a set of a set which n distinct denoted by P and R. N is the distinct option and R is the element. So we calculate the P and R with the product rule that we discussed earlier. Okay, we have P and R, okay, N for the choices, N minus 1 for the second one, because this one is successive from the previous one. Okay, for example, permutation, we have 8, 3, because we have 8, okay, C, we P and R, permutation N and R is equivalent to N factorial divided by N minus R. Okay, N factorial is 8, 7, 6, 5, 4, 3, 2, 1. And then divided by 8 minus 3 is 5, 4, 3, 2, 1, because 8 minus by 3 is equivalent to 5. Okay, how many different set of 3 people can we pick from a group of 6? Okay, so let S be Ali, Chris, and Munandi. If we choose this one is example for permutation, choose 2 members to hold the post of presidential vice president of a society. How many ways of performing of the selection? Order is important for the permutation. So AC, okay, from the AC, P is for president, VP is for vice president. It's not the same for the CA, okay, because the order is important. So N is N is the combination. Combination R is the element. Okay, and then choose two member. Okay, R is the element 3. We have Ali, Chris, and Munandi is R. 2 is considered for N. Okay, the possible combination. So N 3 element factorial divide by 3 minus 2 lah. Okay, factorial. So we have 3 divided by 1. Okay, so we got 6 lah. Okay, boleh ke? Daniel okey ke? Okay. Okay, and then R combination is element of is set an ordered selection of R element. Thus, R combination is simply a subset the set with R element lah. Example, we have S 1, 2, 3, 4 is the element. Remember, for the element for the set, we call it as a R combination lah. Okay, we have C for 2 since is equivalent to 6. Since, for example, the two combination of set, we have 1, 2, 1, 3, 1, 4, 2, 6, 2, 3, 2, 4, and 3, 4. This one is 6 combination. Okay, how we can calculate C combination and R? Consider the following R permutation of the set in the following ways. First, we form the R combination of set. Then we generate all the possible ordering of this combination. Okay, so we can have C and R, P and R divided by PRR. R is the for the uh, distinct combination. N is the distinct, R is the element. Sorry. So we can answer our initial question. Okay, how many groups are there to pick a set of 3 from a group of 6? Disregarding of the order of picking. When you see this regarding is combination is not important. It's for basically for the combination lah. So we have 3 C 6 3. Okay, N is N R. Okay, N now is 6, R is 3 lah. So we got 6 factorial is 720, and 3 factorial multiplied by 3 factorial is 6 multiplied by 6 is 20 lah. The answer is 20 different group to be picked lah. Okay, and then for corollary, for the corollary, let n and r be non-negative integer with whereby the r is less than or equal to n lah. Note that picking a group of R from a group of N is the same as splitting of N people into a group of R and other group of N minus R people. Okay, this one is a combination. Picking two of element and leaving four is essentially the same as picking four element and leaving two. Okay, if we have the four element and leaving two, the same of we have two and leaving four. This one from the n is equivalent to 6. Okay. Okay, another example, a soccer club has 8 female and 7 male members. For today match, the coach want to have 6 male and 6 male player. Female, how many possible configuration are there? Okay, we have two combination here, C86, okay, female and female, male and male, 7 and 5. So for the combination, 8 factorial, okay, based on this formula, okay, we have 28 multiplied by 21, we got 588 lah. Okay. Okay, this one is exercise. Please do in a Padlet lah. Okay. Please do it in a Padlet. Okay. How many ways are there to select 6 students? 6 is the R. Okay, is the element. Okay. From the class of 25, 25 is the possibilities. Okay. To serve on the committee. So we have N PR. Okay, how many ways are there to select 6 students from a class 25 to hold 6 different executive positions on the committee? Okay, we have 25 P6. Okay, class consists of 20 sophomore and 15 freshmen. The club need to choose 4 different members to be president. Okay, this one, we have how many possible? We have NPR, okay, 35 and PH. Okay, and then how many ways if sophomore will be chosen as a president, vice president, and treasurer, and freshman as a secretary. So we have 20. This one is for sophomore. We have P, VP, and T. And then the freshman only we have secretary. So here we have ordered. Ordered mean you have a permutation. Okay, permutation. Okay, make sure the problem that you are relating on is either ordered or in ordered. Okay, so we have NPR, we have 20 P3 product rule multiplied by N2, okay, PR2, and then we got a 15 P1. Okay, also same goes to here. Okay, this one exercise, please do in the Padlet. Okay. Okay, okay, this one assume that you have a group of consisting 5 female and 5 male. You are asked to select a group of consisting of 5 members and you must have at least a female. Okay, from here you list down. You have 5M, 5 female, and then from the 5 C, 5 group, you have 1 female, 4 male, 2 female, 3 male, 3 female, 2 male. Okay, 4 female, 1 male, 5 females. And this one is C5. Okay, and then from T1 plus T2 plus T3 plus T4, you have here is combination. Combination because order is not important. Okay. Okay. Later next week, I show you another example for permutation and combination.